Okay, Algebra 2s, let's look at Unit 5-1 homework, and we can make our key together. Rewrite the expression using radical notation, do not evaluate. So all I need to know is here, I'm looking for the fourth root of 15. Here I'm looking for the ninth root of x squared. Neither of these can be simplified. If I wanted to use the calculator to estimate that, I could, but that's what this part here means, do not evaluate. All right, rewrite the expression using rational exponent. Remember, the word rational is a word for fractions. Remember, that's a ratio of part to whole. So if I have the square root of 2, that's the same as 2 to the 1/2 power. Remember, there's an understood 2 there, and this is 2 to the first power. All right, so I have here the third root, or the cube root of 2x squared is what I have, which means that 2x squared is all to the 1/3 power. Make sure you pay attention that here only the x is squared, not the 2. That's why we can't write this as a 2/3 power, because that doesn't apply to this 2. All right. Simplify the following expressions. Do not give decimal answers, which means that we need to use our chart with all of our friendly numbers on it that might help us. I know that the cube root of 216 is equal to 6. So I know that this answer is -6. If I'm not sure of that, I can always use my calculator that can help me out, and I can ask it what the cube root of -216 is. I could also ask it what -216 to the 1/3 power is. So I can verify this by using either the radical or the rational exponent. Okay, so 125 to the 2/5 power means I'm looking for the cube root of 125 squared. And it doesn't matter if this squared is on the inside like this or on the outside like this, because this applies to this whole value. That's different from that one. So the cube root of 125 is equal to 5, and that squared is equal to 25. So -243 to the 2/5 power, I'm looking for the fifth root of -243, and that whole thing is going to be squared. So 243 might be one of my friendly numbers, but I forgot. And if that's the case, you can go into your y is equal to, and you can say, hey, can you just remind me some of the factors of 243? As soon as I see 3 and 81, I'm like, oh, that's right. And if I want to break it down a little bit more evenly, I can have 9 and 27. Okay, so I have my 9 and 27. Remember, I'm looking for 5 roots, or 5 of the same factor. Here's 1, 2, and I know this is 9 and 3. And here's 1, 2, 3, 4, 5, which means that -2 comes out 5 times, and when I square that, I get +4. All right, the third root of 88. I know 88 is 8 and 11, and I know this is a perfect cube of 2. So I know I end up with 3 factors of 2 coming out, and that 11 is stuck inside. 160, I know that's 16 and 10, and I know this is 4 and 4, and that gives me 4 factors of 2. So even though I have another factor of 2 here, it doesn't matter. because my rule is 4. So one of these 2's comes out, and that 10 is left inside. When I'm looking at 81, again, I know that 81 is going to have 9 and 9, and 3 and 3, 3 and 3, which gives me my 1, 2, 3, 4 factors of 4. So then my 3 comes out, and that's going to give me that cubed. So my answer here is 27. If you're ever getting lost and you're unsure, don't be afraid, especially if it comes out evenly, to check it on the calculator. Go ahead and type in 81 to the 3/4 power. Or you can go ahead and use the math function. And, you got to type in your index first. For math, choice 5. We'll pop that 4 up where it goes. And you want 81. And remember, I want this whole thing cubed. So I'm going to go ahead and insert a parenthesis. Come over here. Close my parens. Oops, not yet. Delete. Now I can close my parens and say this is to the 3rd power. So I know I did it right. Okay, let's take a look at simplifying the following expressions. When I'm looking for a perfect cube, by this time I know 27. I've already done it a bunch of times over here. So I know 3 is going to come out because it has 3 factors of 3. When I look at x to the 6th, if I have 1, 2, 3, 4, 5, 6 x's, and I'm looking for groups of 3, that means that I have 2 of them. Here, this negative hangs out outside. It's a square root. When I look at 48, I know that's 16 and 3. So 16 is a perfect square. 4 comes out, and this 3 is going to be left inside. I leave some space because I know at least 2 of my x's come out as 1. This x is left inside. And then 2 of my y's come out, nothing left inside. My 5th root of 128. So when I go ahead and I think about 128, that's 2 and 64. And that's 2 and 32. And that's 2 and 16. If I'm looking for factors of 2, 4 and 4 gives me that many more of them. So I have 1, 2, 3, 4, 5, 6, 7 factors of 2. I only need 5. So 2 comes out, and those 2 factors of 2 stay inside the radical. None of my x's can come out. I need 5, and I only have 2. My y's come out evenly in 5 groups of 5. Alright, so 343, was that one of your ones that you memorized? Let's go ahead and see. If I want to see, does 343 divide by x give me any numbers I recognize? It sure does. There's 7 and 49, which means that's a perfect cube. So 3 factors of 7, 1, 2, 3, mean that 1 7 comes out, 3 x's come out, and 4 sets of y come out. So that works out evenly. Once everything comes out of your radical, it just goes away because we've simplified it. All right. 16 is 2 to the 4th. So my 2 comes out. 4 groups of x are going to come out. And 5 groups of y are going to come out. Square root, this 2 and x just hang out, waiting to see what else comes. Square root of 25 is 5. Square root of 6 x's is going to be 3. So then I need to multiply my coefficients, 10, and I get x to the 4th power. Okay, so let's look at the back. This is an interesting problem. Read the directions. Identify each expression that's equivalent to the problem. Hint, there are 2 correct answers. And if you look at this, some of these are using radicals and some of these are using rationals, exponents. So I know that 32 is 2 to the 5th. So I know right away 2 comes out. And then I'm going to have 1x come out, 1y come out, and that's going to leave 1x inside, because 5 factors of x made this able to come out. And that's going to leave 2 y's. So 2 factors of y are left inside, because 5 factors of y came out. So when I look, I believe I'm okay with this here. But now when I think about it as a rational, because these x's and y's didn't come out evenly, I know my 2 has an exponent of 1. He doesn't have a rational exponent. But x actually is to the 6/5 power. And y is actually, and I'm looking over here, to the 7/5 power. Because these didn't simplify completely, I recognize that these fractions are going to be the better way of noting it if I'm still working with this. Look how tricky these are. They left 32. That's not right. They left 32/5. That's not right. Check out this. They had 5/6. Wrong. The 5 is in my denominator. So I like this answer a whole lot better. All right, 16 is 2 to the 4th, so one of my 2's comes out. When I look at x, 4 factors of x come out and 3 factors of x are stuck inside. 4 factors of y come out and 2 factors of y are stuck inside. So when I want to find, I know anything beginning with a 4 can't be right. I know 2 and x and y came out, my 4th root, with 3 x's and 2 y's left under the radical. Now when I go ahead and look at it as a rational expression, I know I have my 2's, that's good. I have 7 out of 4 x's, that looks good. I've got 6 out of 4 y's. Check it out. They simplified this fraction. So this here ends up being a tricky part, because if I had written that as a rational exponent, I would have said 2x to the 7/4 times y to the 6/4. But notice this is a fraction that can be simplified. So if we're asked to simplify, we have to do it all the way. All right, solve each equation. Now that I'm solving an equation, I have an equal sign. I'm going to go ahead and I'm going to divide. And my first step is always going to be to isolate my exponent. So 54 divided by 2 is 27, and it's negative. So I'm going to take the cube root of each side. So that gives me x is equal to, that's the opposite of 3. An odd power and a negative is fine. All right, let's talk about this. Negative 3x to the 5th, I'm going to add 16 to each side, is going to be equal to negative 400 plus positive 16. I'm going to say that's negative 384. I'm going to check my math in case I didn't do the math correctly in my head. Negative 400 plus 16. I'm good. Divide by negative 3. Divide by negative 3. So x to the 5th is equal to 1/28. Do you have that in your head right? As far as when I take the 5th root of this, what that value is, 1/28 divided by all the values of x. When I look, 8 and 16, 1/28. 8 and 16. This is 4 and 2, 4 and 4, 2 and 2, 2 and 2, 2 and 2. 1, 2, 3, 4, 5. 2's come out. Oops. My x is equal to, those 5 2's come out, and guess what? I still have 2 left inside. All right, let's check out this one to number 21. Subtract 7 from each side. 3x to the 4th is equal to positive 3. Divide by 3, divide by 3. X to the 4th is equal to 1. Take the 4th root, take the 4th root, and my x is equal to plus or minus 1. Be careful here, because you have to remember that this even power always needs a plus or minus to accompany it. Alright, so I'm going to divide by the negative, and I'm going to say x minus 7 to the 3rd power is equal to negative 729. And I'm going to take the cube root of this whole expression, which is going to give me x minus 7. You don't have to worry about a plus or a minus, because this is odd. So I'll go ahead and just say this is going to be a negative value. And I can go back and think about 729, where I can say, okay, I know that's one of my friendly numbers. What do I recognize? There's 9 and 81. So when I have 729 and it breaks into 9 and 81, and this breaks into 9 and 9, there's my 3 factors right there. So then when I add 7 to each side, I get x is equal to negative 2. Alright. Now we're going to have a similar situation, but be careful. This one was an odd power. This one's an even power. This one we're going to need to take care of and include our plus or minus. So I have x plus 1 to the 4th power is going to be equal to 30. That's an interesting choice. Alright, so the 4th root. So I get x plus 1 is equal to plus or minus the 4th root of 30. So when I have subtracting 1, I get x is equal to negative 1 plus the 4th root of 30. And I have x is equal to negative 1 minus the 4th root of 30. Alright, last one. Divide by 2. Divide by 2. X plus 3 to the 4th is going to be equal to 16. I know 2 to the 4th is equal to 16. So when I take this 4th root, I have x plus 3 is equal to plus or minus 2. So when I subtract 3 from each side, I get x is equal to negative 3 plus 2, and x is equal to negative 3 minus 2. X is equal to negative 1, and x is equal to negative 5. There are 2 solutions for x for this one. All right, good job.